Binomial. A binomial distribution has two components to it. Binomial distribution has two components to it. It's got a number of trials n and a probability of success p. So two things that you will need to work with binomial to identify a binomial distribution. We have a set number of trials. That's n. And then we have the thing that we're keeping track of is classified as, the book calls it a success or failure. I usually called it the thing happens or the thing doesn't happen. So we have a probability P of a thing happening. And the variable for a binomial distribution is number of times that the thing happens. That is our variable in a binomial distribution. So that's how we know what to look for with a binomial distribution. We have a thing that we're keeping track of whether it happens or it doesn't happen. We have a probability of that thing happening that stays consistent throughout. That's my two kind of pieces that go into the formula. Is a set number of trials and then the probability of the thing happening. Then our variable is the number of times that the thing happens. And that's what we're usually trying to find the probability of. This is as opposed to geometric, which has all the same components. We're keeping track of whether the thing happens or it doesn't. The only difference in geometric, and geometric is easier than binomial. Geometric is keeping track of how many trials happen until the first success. How many times until the thing happens. And the formulas for those are pretty intuitive, so I'm not going to go over that in too much detail. The ones I'm going to do is binomial. So I'm going to look at this practice, this multiple choice problem, and I'm going to break down how do I know this thing is binomial. Well, first off, a person can win a prize by guessing one of 5 identical boxes. When the prize has been won, a new prize is randomly placed in one of the 5 boxes. So this is what we're keeping track of. The thing happening or not is winning the prize. Do we win the prize or do we not win the prize? So this is our probability of a success, and that's 1 in 5. Now 1 in 5 stays the same every time because I put a new prize into the box at random, so the probability stays 1/5 every time. Good so far? Okay, number of trials. If it's binomial, then we have a fixed number of trials, a fixed number of times that we are doing the thing, which would be the number of times that we are trying to win a prize. The number of times in total that we are going to attempt to win the prize, which is 4. So n, in this case, is 4. So we know it's binomial because we have a number of trials. We have 4 times that we're going to attempt the thing. And then we have a probability of the thing happening, which is 1/5. And we're keeping track of how many prizes do I win. So probability that the person wins the prize exactly 2 times is the probability that X equals 2. So that's how I know it's a binomial distribution. And my formula for that, this is right on the formula sheet for binomial. So the formula for that is going to be E. Here is how many times I want the thing to happen. I want it to happen twice. I want it to not happen twice. And then here are the different ways that it could happen 2 times out of 4, which is the 4 choose 2. In the calculator, this can be done with Binomial Pdf. Binomial Pdf is what we would do for probability that X equals a certain value. Binomial CDF would be the probability that X is less than or equal to a certain value. So everything at that level or less is what binomial CDF is. So sometimes we're finding the probability that it happens exactly that number of times. But if we're trying to find the probability that it happens a range of values of times, that's CDF. And it will always give you the less than or equal to. So like if I wanted the probability of greater than 2, then I would take the less than or equal to 2 and then take 1 minus it. All right. Between these 3 parts, the binomial question is hidden within. Did we correctly identify that it's in part B? Part B, we have our N, our number of trials, is 20. Our probability of the thing happening is 0.1. The thing that we're looking to happen is the upgrade. So our fixed number of trials is 20. Our probability of a success is 0.1. And we are keeping track of the number of times that the thing happens. And so we're finding the probability that X equals 2. So we're going to use Binomial Pdf to solve that.